In the decades following the Second World War, Soviet military planners concluded that future large-scale war in Europe would not be decided solely by the mass of armored divisions or the density of artillery, but by the ability of front-level formations to sustain continuous offensive momentum across hundreds of kilometers under conditions of intense attrition. And from this assessment emerged a comprehensive logistics doctrine centered on the concept of the operational front, a wartime formation typically composed of several combined arms armies supported by dedicated rear services, structured to maintain uninterrupted supply of fuel, ammunition, food, spare parts, and replacement equipment at a tempo aligned with deep offensive operations. And unlike Western logistics models that often emphasized decentralized sustainment at corps or divisional level, Soviet doctrine elevated front-level logistics to a centralized operational instrument, embedding rear service command structures directly within front headquarters to ensure that material flow was synchronized with planned axes of advance, breakthrough timing, and exploitation depth. And this approach was rooted in wartime experience from 1943 to 1945, when Red Army offensives had demonstrated that logistical pauses could dissipate operational shock, allowing German defenses to stabilize, and therefore post-war doctrine emphasized the elimination of supply discontinuity as a prerequisite for rapid successive operational thrusts. And by the early 1950s, the Soviet General Staff codified these lessons into detailed regulations defining the composition of front-rear services, including pipeline brigades, railway troops, motor transport regiments, ammunition depots, fuel storage echelons, and repair and recovery units positioned in successive depth behind advancing armies, forming a layered sustainment architecture designed to move forward as the front advanced. And within this framework, logistics was not treated as a static support function, but as a maneuver element whose placement and protection were integral to operational design, because the speed at which supplies could be repositioned determined whether armored formations could maintain breakthrough momentum or would stall awaiting resupply. And the creation of the Warsaw Pact in 1955 extended this doctrinal model beyond Soviet territory, as Allied states such as Poland, East Germany, Czechoslovakia, and Hungary were integrated into a unified operational planning system in which their rail networks, depots, and transport assets were subordinated to front-level plans generated in Moscow. And this integration required harmonization of rail gauge interfaces, standardized fuel types, common ammunition calibers, and coordinated stockpile distribution across national boundaries, ensuring that in wartime, front commands operating on the Central European theater would have access to prepositioned resources measured in days of supply calculated, against projected rates of expenditure per tank battalion and artillery regiment. And by the 1960s, Soviet front-level logistics doctrine had matured into a detailed system specifying normative consumption rates, such as liters of fuel per kilometer of tank advance, artillery rounds per day during breakthrough phases, and tonnage requirements per combined arms army over successive 72-hour operational cycles, enabling planners to estimate the number of trains, trucks, and pipeline segments required to sustain a front advancing at planned rates of 30 to 40 kilometers per day during exploitation. And this quantification shaped Warsaw Pact war planning profoundly, because operational maneuver groups envisioned in later decades required sustained high-speed advance deep into NATO territory, a concept feasible only if front-level rear services could reposition depots, extend pipelines, and repair rail corridors in near-continuous sequence behind advancing spearheads, and, therefore, Soviet investment in railway troops, pipeline construction battalions, and heavy transport regiments reflected doctrinal emphasis on mobility not only of combat units, but of supply infrastructure itself, creating a dynamic rear area designed to move forward in echelon. And as NATO analysts observe the density of Warsaw Pact rail corridors feeding East Germany, and the scale of ammunition and fuel stockpiles maintained in Poland and Czechoslovakia, they recognized that front-level logistics doctrine was central to the Pact's ability to concentrate and sustain mass along the central front. Because without synchronized rear services, even the largest armored formations would be constrained by fuel depletion and ammunition exhaustion within days. And thus, from its post-war codification through successive refinements in the 1960s and 1970s, Soviet front-level logistics doctrine became the structural backbone of Warsaw Pact war planning, embedding quantifiable sustainment depth into operational art and shaping the alliance's expectation that rapid offensive momentum could be maintained across extended distances through centralized echeloned rear service coordination, integrated directly into front command structures. By the late 1950s and into the 1960s, Soviet front-level logistics doctrine had evolved from general post-war principles into a highly structured operational system, codified in field regulations, and integrated directly into Warsaw Pact war planning. Because the General Staff concluded that modern mechanized warfare would consume fuel and ammunition at rates far exceeding those of the Second World War, particularly with the proliferation of main battle tanks, self-propelled artillery, rocket forces, and tactical aviation operating in coordinated deep operations, and therefore logistics calculations were formalized around normative expenditure tables that defined expected daily consumption per division during breakthrough, exploitation, and pursuit phases, including specific figures for artillery rounds per kilometer of frontage, liters of diesel per tank battalion per day under high-tempo advance, and replacement rates for vehicles lost to mechanical attrition or combat damage, enabling planners to estimate the total tonnage required to sustain a front composed of multiple combined arms armies over a 72-hour operational cycle. And these estimates were then translated into transport requirements expressed in rail cars per day, truck sorties per hour, and pipeline flow rates measured in cubic meters of fuel, forming the quantitative backbone of front-rear service planning. And within this architecture, the front's deputy commander for rear services held authority over an extensive logistical structure, including material support brigades, ammunition depots echeloned in depth, fuel distribution regiments equipped with tanker vehicles and mobile pumping stations, and repair and evacuation units tasked with recovering damaged equipment and returning it to service within compressed timelines. Because Soviet doctrine emphasized minimizing pauses between successive operational thrusts, and thus the mobility of rear services was considered as critical as the maneuver of armored spearheads, and railway troops played a central role in this design, assigned responsibility for restoring damaged track, constructing bypass lines around destroyed bridges, and converting captured standard gauge rail lines to Soviet broad gauge where feasible, ensuring continuity of heavy freight flow toward advancing forces, while pipeline brigades were tasked with extending temporary fuel pipelines forward as front lines shifted westward, reducing reliance on vulnerable road tanker convoys and enabling sustained fuel flow measured in hundreds of tons per day to forward depots. And this layered rear area structure was organized into successive echelons, with forward supply points positioned relatively close to Army, boundaries to support immediate consumption, intermediate depots located farther to the rear for replenishment, and strategic reserves maintained in depth within national territory, allowing front commanders to draw upon staggered stockpiles calculated to provide multiple days of high-intensity combat sustainment, even if rail corridors were temporarily disrupted. And as the Warsaw Pact integrated Allied states into a unified operational framework, after 1955, Front-level logistics doctrine required harmonization of fuel types, standardization of ammunition calibers, and coordination of depot locations across Poland, East Germany, Czechoslovakia, and Hungary, effectively subordinating national logistics networks to centrally directed war plans that assumed rapid concentration along designated axes of advance toward the North German Plain, or Fulda Gap. And NATO intelligence assessments during the 1960s increasingly identified the density of Warsaw Pact railheads and the scale of ammunition storage facilities in forward areas as indicators of front-level sustainment depth, noting that the Pact's emphasis on centralized rear services allowed it to preposition vast quantities of material within relatively short distance of the central front, thereby reducing the time required to initiate sustained offensive operations. And as Soviet operational art continued to refine concepts of deep battle and operational maneuver, logistics planning adjusted accordingly, incorporating projections for rapid exploitation phases in which armored units might advance tens of kilometers per day, requiring fuel delivery schedules tightly synchronized with movement timetables and replacement vehicle dispatch calculated against projected attrition rates, demonstrating that front-level logistics doctrine was not a static support function, but an integrated component of operational design whose quantitative modeling shaped every aspect of Warsaw Pact war planning from mobilization through sustained advance. As Soviet operational thinking advanced into the 1970s, front-level logistics doctrine was further refined to support increasingly ambitious concepts of deep operations that envisioned not merely sequential breakthroughs, but simultaneous, layered offensives designed to penetrate NATO defenses across multiple axes and exploit into operational depth before Western reinforcements could stabilize the front. And this evolution required rear services to be organized not only for sustained supply, but for synchronized mobility under high-speed maneuver conditions, prompting doctrinal emphasis on pre-calculated logistical cycles aligned with operational phases, in which each combined arms army within a front was assigned consumption norms tied to specific mission tasks such as initial breach, exploitation toward intermediate objectives, and transition to pursuit. And these norms were consolidated at the front headquarters into aggregate tonnage requirements measured in thousands of tons per day, which were then matched against available rail capacity, truck fleet strength, and pipeline throughput, forming a comprehensive sustainment schedule integrated directly into the operational plan, and to ensure resilience against anticipated NATO air interdiction. The Soviet General Staff mandated redundancy within rear area structures, including parallel supply routes, dispersed ammunition storage sites, camouflaged fuel depots, and prepositioned repair materials for rapid restoration of damaged infrastructure, while railway troops were trained to operate under combat conditions with prefabricated track segments and bridging kits capable of restoring rail corridors within hours, reflecting an understanding that rail flow was the primary artery sustaining heavy front-level operations, and pipeline brigades were similarly structured for mobility, equipped with portable pumping stations and flexible hose segments that could be extended forward in successive stages as armies advanced, reducing reliance on truck transport for bulk fuel and thereby lowering exposure to air attack. And maintenance and recovery units were organized in depth to evacuate damaged armored vehicles to field repair facilities positioned just behind the forward line of contact, minimizing equipment losses and sustaining armored density during prolonged offensives. And these doctrinal refinements were exercised during large-scale maneuvers, such as Zapad 77 and later Zapad 81, where logistical units rehearsed rapid depot relocation, rail unloading under simulated air threat, and synchronization of fuel extension with mechanized movement, generating empirical data on truck sortie rates, repair turnaround time, and ammunition resupply intervals, which were fed back into normative planning tables maintained by the General Staff. And as Warsaw Pact allies expanded their own mechanized formations in alignment with Soviet force structure models, front-level logistics, doctrine was adapted to incorporate multinational rear area integration, requiring coordinated rail scheduling across Poland and Czechoslovakia, standardized fuel distribution protocols within East Germany, and unified reporting procedures to ensure that consumption data from subordinate armies could be aggregated accurately at front headquarters, enabling real-time adjustment of supply priorities based on operational tempo. And NATO analysts during this period increasingly assessed that the Pact's ability to sustain high rates of advance for multiple days without operational pause was rooted not solely in armored mass, but in the systematic centralization of front-level rear services, which allowed planners to project cumulative sustainment depth of 5 to 7 days at high-intensity expenditure before strategic reserves would need to be committed, a calculation that shaped Western defensive modeling by compressing the time available for reinforcement and counter-concentration. And thus, by the late 1970s, Soviet front-level logistics doctrine had evolved into a dynamic, quantitatively modeled system designed to maintain continuous offensive momentum through centralized coordination of rail transport, pipeline extension, truck distribution, and repair services. Embedding logistical mobility at the core of Warsaw Pact war planning and reinforcing the operational assumption that rapid mass thrusts could be sustained deep into NATO territory without premature culmination. During the late 1970s and into the 1980s, Soviet front-level logistics doctrine was increasingly calibrated against the expectation of high intensity, possibly short-duration, conventional war in Central Europe, in which operational success depended on achieving decisive results before NATO reinforcement and mobilization cycles could fully mature. And this temporal pressure reinforced the doctrinal requirement that front-rear services maintain uninterrupted sustainment for the initial operational period, commonly projected at 3 to 7 days of intense combat, during which consumption of fuel and ammunition would reach peak normative levels, and planning tables maintained by the General Staff calculated daily expenditure for a single tank division in breakthrough operations at thousands of artillery rounds and hundreds of tons of fuel, figures that multiplied rapidly when aggregated across multiple armies within a front, compelling rear service commands to preposition large stockpiles in forward areas of East Germany and Poland, sufficient to support these projected burn rates without immediate reliance on strategic depth resupply. And such stockpiles were dispersed across hardened storage sites and camouflage depots to reduce vulnerability to NATO air interdiction, while railheads were constructed with multiple parallel sidings to accelerate unloading of ammunition trains measured in dozens of wagons per echelon, allowing simultaneous offload to motor. Transport battalions equipped with standardized tanker trucks and cargo vehicles and pipeline brigades continued to refine rapid extension techniques, rehearsing forward displacement of fuel distribution nodes in coordination with projected axes of armored advance, ensuring that bulk fuel flow could be maintained at rates sufficient to sustain mechanized formations advancing tens of kilometers per day, and maintenance and recovery doctrine emphasized rapid battlefield evacuation to forward repair units capable of restoring damaged vehicles within 24 to 48 hours, preserving combat mass and reducing the need for replacement from strategic reserves. And these procedures were validated during major exercises such as Zapad 81, which integrated rear service maneuver into operational scenarios, testing the capacity of railway troops to restore disrupted corridors under simulated air attack and measuring truck sortie rates required to maintain Army-level supply under conditions of dispersed combat, generating data that refined logistic norms and reinforced centralized control at front headquarters, and multinational coordination within the Warsaw Pact further matured during this period. With Allied rail networks synchronized to support Soviet mobilization timetables and standardized reporting mechanisms ensuring that supply status from Polish, East German, and Czechoslovak depots could be consolidated into a unified front logistics picture, allowing rapid reallocation of resources if one axis consumed material faster than projected. And NATO intelligence assessments during the 1980s increasingly emphasized that Warsaw Pact war planning assumed the ability to sustain continuous offensive operations without extended operational pause during the initial campaign phase. Attributing this confidence to the centralized echelon structure of front-level logistics, which integrated rail transport, pipeline extension, motor distribution, and repair services into a coordinated sustainment architecture capable of delivering thousands of tons per day to advancing armies. And thus, as the Cold War approached its final decade, Soviet front-level logistics doctrine stood as a mature, quantitatively modeled system designed to preserve offensive momentum through depth, redundancy, and centralized command integration, shaping Warsaw Pact war planning by embedding sustainment capacity directly into operational design and reinforcing the expectation that rapid, sustained thrusts could be maintained against NATO defenses during the decisive opening phase of a European conflict. In parallel with the refinement of consumption norms and transport coordination, Soviet front-level logistics doctrine in the 1980s increasingly emphasized operational resilience under conditions of NATO deep interdiction, because Western air power doctrine, particularly after the emergence of air-land battle concepts, signaled a clear intent to target second echelon, formations, rail corridors, fuel depots, and command nodes deep behind the forward line of contact. And Soviet planners responded by restructuring rear service deployment patterns to reduce single-point vulnerability while preserving centralized control, dispersing ammunition and fuel stocks across multiple smaller storage areas, rather than concentrating them exclusively in large depots, hardening selected facilities with earth revetments and reinforced overhead cover, and pre-surveying alternate rail unloading sites to ensure that if a primary railhead were disabled, trains could be rerouted to secondary locations within the same operational depth, maintaining continuity of supply flow measured in daily tonnage, and railway troops expanded training in rapid track repair and bridge reconstruction, using prefabricated spans capable of restoring damaged crossings within hours. Acknowledging that uninterrupted rail throughput was essential to sustaining front-level expenditure rates, calculated in thousands of tons per day, while motor transport brigades rehearsed dispersed convoy movement under simulated air threat, adjusting march discipline and spacing to reduce vulnerability, and pipeline units refined techniques for rapid repair of ruptured lines, maintaining fuel flow even under interdiction, because fuel was identified as the pacing commodity for armored maneuver. And within front headquarters, the deputy commander for rear services maintained centralized authority to reallocate supply priorities dynamically, shifting ammunition or fuel allocation between armies based on real-time consumption reporting, ensuring that breakthrough sectors retained priority support while less active axes operated at reduced expenditure, reflecting a doctrine that treated logistics as an adaptive operational instrument rather than a static allocation, and multinational integration within the Warsaw Pact reinforced this resilience model, with Allied states maintaining designated rear service units prepared to integrate into Soviet front structures, their rail and road networks pre-assigned within operational plans to carry specified tonnage per day during mobilization and advance. and NATO analysts observed that Warsaw Pact exercises increasingly incorporated simulated disruption scenarios to test whether front-level sustainment could absorb interdiction without operational pause, indicating that Soviet doctrine recognized vulnerability yet relied on redundancy and centralized coordination to mitigate it. And by the mid-1980s, front-level logistics had thus evolved into a system designed not only for high-volume throughput under ideal conditions, but for sustained output under degraded infrastructure, integrating rail, pipeline, and motor transport into a layered network capable of shifting nodes and restoring capacity quickly, reinforcing the Warsaw Pact assumption that initial offensive momentum could be preserved even in the face of Western deep strikes. And embedding within war planning the expectation that sustainment depth, calculated in days of supply and cumulative tonnage available in echelon, would allow mechanized formations to advance continuously through the critical opening phase of a European conflict without culminating prematurely due to logistical exhaustion. By the late 1980s, as both NATO and the Warsaw Pact refined increasingly sophisticated operational models, Soviet front-level logistics doctrine had become inseparable from the broader concept of operational maneuver groups and second echelon commitment, because war planning assumed that once first echelon combined arms armies achieved initial breakthroughs, follow-on forces would be introduced rapidly to exploit gaps and drive deep into NATO rear areas. And this sequencing required that logistics planning account not only for current consumption, but for the staged introduction of additional armies whose fuel and ammunition requirements would compound daily tonnage, demand, often doubling or tripling rail and pipeline throughput within compressed timeframes. And therefore, front-rear service staffs developed phase sustainment schedules that aligned supply surges with projected commitment timelines, pre-designating rail corridors and depot release points for second echelon formations, so that material flow could expand without disrupting ongoing support to first echelon units. While strategic reserves held deeper in Soviet territory were allocated to specific fronts in advance, ensuring that replenishment trains could be dispatched according to predetermined priority matrices, and centralized reporting procedures required subordinate Army rear services to transmit daily consumption data upward, allowing the front deputy commander for rear services to recalibrate distribution and prevent imbalance between axes of advance, reflecting a high degree of administrative integration designed to maintain operational tempo across successive thrusts. And infrastructure investments in allied Warsaw Pact states continued to support this model, with expanded rail marshalling yards in Poland and East Germany capable of handling increased train density, fuel storage complexes positioned along projected axes of advance with capacity measured in tens of thousands of tons, and repair depots structured to process armored vehicle refurbishment at rates sufficient to return damaged equipment to combat within 48 hours under surge conditions. And NATO intelligence assessments during this period increasingly emphasized that the Pact's ability to project sustained offensive power for several days without pause derived not only from massed armored formations, but from the deliberate alignment of logistics doctrine with operational art, in which sustainment depth was pre-calculated, infrastructure pre-assigned, and multinational networks subordinated to front-level command authority. And yet by the close of the decade, the political and strategic environment was shifting rapidly as reform movements within Eastern Europe and the Soviet Union introduced uncertainty into long-standing mobilization assumptions. But the doctrinal architecture itself remained intact through 1991, embodying decades of refinement in which rail transport capacity, pipeline extension capability, motor distribution density, and repair and recovery throughput had been quantitatively integrated into war planning, ensuring that from mobilization through exploitation, front-level logistics doctrine provided the structural backbone enabling Warsaw Pact operational design to assume continuous high-tempo maneuver deep into NATO territory during the decisive opening phase of a potential European conflict. When examined across the full Cold War period, from the consolidation of Soviet post-war doctrine through the dissolution of the Warsaw Pact in 1991, front-level logistics emerges as the structural foundation upon which Warsaw Pact war planning was constructed, because Soviet operational art assumed that decisive results in Central Europe would depend on sustaining mechanized momentum beyond the initial breakthrough, and such momentum required not episodic resupply, but a continuous, centrally directed flow of fuel, ammunition, and replacement equipment calibrated to normative expenditure rates calculated for each phase of combat. And this calibration translated directly into quantifiable infrastructure requirements, including rail throughput measured in train loads per day, pipeline extension capability expressed in cubic meters of fuel flow, truck fleet density sufficient to distribute thousands of tons forward under dispersed conditions, and repair capacity designed to restore damaged armored vehicles within compressed timelines. And throughout successive decades, the General Staff refined these variables into an integrated rear service architecture embedded at front headquarters under a deputy commander for logistics empowered to reallocate resources dynamically across armies, ensuring that priority sectors receive sufficient sustainment to maintain tempo, while less active axes adjusted to available stockpiles, and multinational integration within the Warsaw Pact extended this architecture across Allied rail and road networks, subordinating national logistics assets to unified operational plans that pre-assigned corridors, depots, and stockpiles in anticipation of rapid mobilization and advance. While exercises such as Zapad validated throughput assumptions and stress-tested redundancy under simulated interdiction, reinforcing the doctrinal expectation that sustainment depth measured in multiple days of high-intensity supply could be preserved even under attack. And NATO analysts consistently assessed that this centralized echeloned rear service model enabled the Pact to plan for sustained offensive operations across successive operational phases without premature culmination, compressing the window available for Western reinforcement and shaping alliance defensive modeling accordingly. And although the geopolitical confrontation that defined the Cold War ended without these plans being executed, the institutional development of front-level logistics doctrine left a comprehensive legacy of quantitative planning, infrastructure investment, and command integration that had shaped Warsaw Pact military thinking for decades. Embedding logistics not as an auxiliary support function, but as an operational instrument whose calculated capacity underpinned the feasibility of deep offensive maneuver in European war scenarios from the 1950s through 1991.